Hello students, welcome back to the microeconometrics course. In this lecture, we're going to discuss the topic of difference in differences model. Let's start. So we'll start off with a motivation on why we want to do difference in differences model and how this model can actually be applied using observational data. So one of the challenges in microeconometrics is to obtain a valid counterfactual. We've discussed a lot about counterfactual, and you guys should be able to provide examples of counterfactual when you're thinking about impact evaluation or policy evaluation. So it is usually difficult to obtain a valid counterfactual using observational data such as national surveys or perhaps panel data such as the Indonesian Family Life Survey. So in general, treated units are more likely to have different characteristics than non-treated units. For example, on average, those who receive program Keluarga Harapan are poorer than those who do not receive the program Keluarga Harapan. So again, in general, they're different not only on characteristics that we can observe, but more to the characteristics that we do not observe. So one way of getting around this is to actually use pre-treatment outcomes, so outcomes before the program was implemented. And the key here is not only to look at units that are treated, but also units that are not treated. So difference in differences strategy is to model the role of pre-treatment outcomes. Okay. So let's start with the data structure that we need for difference in differences model. So we can do at least 2 waves of cross-section data. We'll see why we need more than 2 waves in several slides. And as an alternative, we can also use panel data. So suppose that we're going to do pool cross-section, and what we want to have is that for each year, or for each period, we want a cross-sectional units. For example, we have n individuals, or perhaps we have n households, or perhaps other kinds of observations like firms, etc. We also want to have time periods. Here, for the sake of an example, we're going to use just 2 periods. The first period is before the program or the intervention was implemented. That is also called the pre-treatment. And also another period after the program was implemented, and we're going to call this the post-treatment. Now, given the cross-section sample that we have for each period, we're going to divide individuals who get the treatment, or any unit that gets the treatment, and those who do not get the treatment. So we have here a simple binary variable of an indicator that indicates the receipt of a treatment. Now for this study, I'm going to use a study by Keel and McLean to explain the basic intuitions of difference in differences model, and that would provide you with better sense on how we're actually going to take advantage of this particular method. Okay, so the question posed by Keel and McLean is actually quite straightforward. So what is the effect of the location of garbage incinerator on house prices? So this is a very simple depiction of garbage incinerator, and as you can see, there are going to be some externalities, and particularly negative externalities with having this garbage incinerator. So for example, there's going to be a lot of smokes, there's going to be a lot of pollution, and that would actually reduce the quality of the environment. And you can imagine that perhaps you don't want to live in an environment where the air pollution is actually quite high or quite severe. So in general, we can think that having a garbage incinerator within a perimeter of our house is actually going to decrease the value of that houses. So it will be important to actually evaluate the impact of having this garbage incinerator around the perimeter of houses. And so as we've talked about, we have this hypothesis that having an incinerator nearby lowers the price of a house. However, we really want to know by how much. So the data that we're going to need for evaluation on the impact of garbage incinerator is at least the following. We need the prices as well as the characteristics of houses in different distances to do incinerator. So the idea is that we want data on houses and its characteristics. On houses that are relatively close to the garbage incinerator and houses that are actually quite far away from the incinerator. So and then we'll also want to do 2 periods, at least 2 periods. We're going to see why we need more than 2 periods in several sites. The first one is a period before the garbage incinerator was established or was built, and in this particular example it's going to be in 1978, and that is another period when after the establishment or after the garbage incinerator was built, and in this particular case it's 1981. So I briefly touched upon the fact that we want 2 groups of houses, so houses that are relatively close to the garbage incinerator and houses that are quite far away from the garbage incinerator. So in this particular case we're going to have a simple binary variable called near inc, and the value is going to be 1 if the houses is near the incinerator, and it's going to be 0 if it's far away from the incinerator. Of course you might ask how far away and how far is far and how near is near. So you can take a look at the paper to see how they actually decided on the use of parameter to identify which is near the incinerator and which is far away from the incinerator. So that's kind of like how they devise this characterization of whether it's near or whether it's far. Okay, so we'll start with what's called a naive approach. I think this is a method that you guys have learned in the previous lecture. This is also referred to as the with and without approach, or the simple difference approach. So the idea is that we're going to compare using the post-treatment data prices of houses that are near the incinerator and prices of houses far away from the incinerator. And we want to see by how much the prices actually differ in these 2 settings. Okay, so for this particular exercise, we want to do a simple linear regression of log of prices on a dummy variable referred to as the near inc. So again, our parameter of interest is going to be gamma 1. So gamma 1 is going to indicate the difference in prices between houses far away from the incinerator and houses near the incinerator. Okay, so the main question is this going to be a good estimate of the causal effect on house prices of locating the incinerator nearby? Now, before we answer that question, I actually want to do some light exercise in Stata. Trying to get you guys all acquainted with the data so that you can work independently to learn more about this difference in differences model. Okay, so I'm gonna upload the data. The data is going to be KLMC. This is a data provided by Jeffrey Woolridge Introductory Econometrics textbook. So you can download this for free in the website, and the data set is called the KLMC.dta. So I guess a good practice before we actually start doing any kind of like data analysis is to actually know what's inside the data. So you can use the describe syntax in Stata, and of course Stata is quite clever, so you can actually use abbreviation for describe. For in this example, it's going to be just DESC or desk. Okay, so when we hit enter, we're gonna observe that the KLMC data provides 321 observation of houses and their characteristics, and there are 25 variables that we can use for the analysis. And so basically, given the number of observations and given the number of variables, so the size of observations is the following. Okay, so we can see the variables and the label for that variable. We have here age of the house in particular, and then the square age of the house, indicator of neighborhood, and then distance to central business district, distance to the interstate, which is the highway, the lock of the interstate, selling price, and so on and so forth. So we have a lot of variables that we can use for the estimation on the impact of the incinerator. Now, however, I think for the first exercise we want to do is a simple difference or a with and without analysis. So what I want to do is I want to do a simple linear regression of log price and an indicator or a binary variable called near inc after the incinerator was implemented, which is in 1981. Okay, so let's hit enter and let's see what the result is. Okay, so the result of the linear regression suggests that on average the price of houses near the incinerator is 40% lower than prices of houses far away from the incinerator, which is quite large, that 40% difference. Now, again, going back to the discussion, do we really want to claim that this is the impact of the incinerator, or 40% is overestimated, or perhaps is it underestimated? So this is something that we need to think before we can actually claim that the difference of 40% is really due to the incinerator, or we can fully attribute the 40% difference of house prices to the garbage incinerator. So the answer is actually no. We cannot attribute fully the difference of 40% due to the garbage incinerator. Well, there are a lot of reasons why we can't attribute the 40% difference just to the garbage incinerator alone. Well, we can think, well, perhaps houses that are located in area in which the garbage incinerator is built are actually quite different with houses that are located far away. If you think from the government or the policymaker perspective, if you want to provide permission for a company or for an organization to build a garbage incinerator, you wouldn't want to give permission to build it in the center of the city where property prices is relatively high. We don't want to provide a permission to build it in areas where it's quite affluent, and so they're probably going to give a permission to build the incinerator in a place that property price is probably not that high, and it's actually quite far away from houses. So that's kind of like one of the reasons why the 40% difference in house prices between those who are far away and near are actually not a full it's not the full effect of incinerator alone. It could be to the fact that the characteristics of the neighborhoods of houses near the incinerator and that those far away from the incinerators are very different. The amenities are very different: availability of schools, availability of hospitals, availability of other public services. So that's something that we need to take into account when we're dealing with this before and after, or with or without method. So in general, another thing that we need to consider is that house prices may have gone up between 1978 and 1981 for most of the houses in the sample. And this is true not only houses that are close to the incinerator, but also houses far away from the incinerator. So you can think of that, houses far away from the incinerator is going to increase by perhaps 10% between 1978 and 1981. But houses near the incinerator is also going to increase. They're also going to have the prices increase. Now the question is whether the increase in price of houses near the incinerator is going to be just as high as the increase in prices of houses far away from the incinerator. So that's something that we want to do. Now, however, before we proceed into addressing that particular idea, I actually want to introduce you guys to another evaluation methods that we can do to identify the impact of garbage incinerator. I'm not saying that this is a the most appropriate method, but I believe for the sake of discussion, you need to see this particular method. So if you guys recall, in the previous lecture we discussed about the with and without method, but we also discussed about the pre and post method. So this is something that we want to do. So again, we will still want to do linear regression of log of price. However, what we want to do now is we want to do it before and after. So for that particular exercise, I want to do I dot year. So I'm doing this I dot year just because we want to see the differences between 1978 and 1981. So the I dot here is actually you telling Stata to say that, hey, the year variable is going to be an indicator variable instead of a continuous variable. So we're going to focus just on those who receives the treatment. So it's going to be just houses near the incinerator. So it's going to be break of log of price to the year variable for those near the incinerator. Okay, so let's take a look at the result. Well, as you can see, the estimated coefficient for the pre and post method is 0.39. So if we interpret this regression result, so after the incinerator was built, the price of houses near the incinerator actually increased by 39%. Well, it's quite high, one. Second, you're going to shock a lot of people that if you want to claim this as an impact of the incinerator, saying that, there is a positive impact of the incinerator on the prices of houses, because you're giving evidence that the increase is quite high at 39%. Now, again, we have to be careful that we don't want to use this as an estimate of the impact, because a lot of things change between 1978 and 1981. So we cannot really attribute the change. The 39% change is actually due to the garbage incinerator. It could be the fact that it's the macroeconomic conditions. People have higher purchasing power, so there's going to be a higher demand of houses in the area, both far away from the incinerator and areas near the incinerator. So demand for houses increases, that's going to drive up the prices. So the difference of 39%, we cannot really attribute this to the impact of the incinerator. Now, just to give you a hint on how we're actually going to proceed with this analysis, is that let's do the same analysis. However, instead of looking at houses near the incinerator, let's look at houses far away from the incinerator. Now, the results, is as expected. Prices are going to increase between 1978 and 1981. And in particular for this group of houses, the prices increased by 45%. So for houses far away from the incinerator, the increase in prices was 45%. However, for houses near the incinerator, the increase in prices were 39%. So that's kind of like the idea where we're going with the difference in differences approach. We actually want to compare the changes in the price of houses between those located near the incinerator and those far away from the incinerator. Okay, so in particular, we need to look at the differences in space. So in this particular case, is nearby and far away of differences in time. So between 1978, that's before the garbage incinerator was established, and 1981, after the garbage incinerator was actually established. So this particular method is referred to as the diff in diff, or usually just the DID. Okay, so the difference in differences method, or the DID, compares the changes and outcomes over time between a population that is enrolled in a program, the treatment group, and a population that is not enrolled in the program, or we're going to call it this, the comparison group. Of course, again, this is just a generalization on the treatment and the comparison group. Of course, different study and different evaluation is going to have a different label on which one is going to be the treatment and which one is going to be the comparison group. Okay. Now we'll go back to the garbage incinerator example in a while, but let's discuss the particularities of this difference in differences model. So the question is, why do we need to compare the changes over time? And why not just compare the post-treatment outcomes of the two groups? So let's continue into the model setup for the DID. So let treat be the treatment group and control the control group. And let post be a time period dummy equal to 1 for a unit in the second time period, or observation in the second time period. And let pre be a time period dummy equal to 1 for a unit in the first time period. So we're going to write it as the following. So YIT, that's going to be the outcome of interest. And then beta 0 plus beta 1 indicator variable of whether or not a unit receives the treatment or treat. And then the post binary variable. And then an interaction between whether or not a unit receives the treatment treat and the post time indicator. Okay, so this is going to be the basic model setup for our DID. And of course, as you go along and learn a lot of implementation of DID in different models, you can see that there are a lot of variations of DID. But if you can master the idea behind the basic and the simple model of this DID, then you can go far with DID in terms of the variation and how you can take full advantage of different DID setting. Okay, and of course with all the model, we're going to assume that the mean value of the factors that we don't observe is going to be 0. Okay, so let's think about the DID model in the context of pre and post method and with and without method. And here you can actually learn why the pre and post method are going to produce a relatively biased result, and the with and without method also going to produce a relatively biased result. Okay, so let's start. Now suppose that you have observations before and you have observation after for the control group. Now before the outcome on this is y. What's the value of y for the control group before the implementation of the program? Okay, so the average value of y for the control group or the comparison group before the program was implemented is beta 0. Okay, and then the average value of outcomes for the comparison group after the program was implemented is going to be beta 0 plus delta 0. Okay, now if you take before and after, the difference is going to be delta 0. Now let's keep what delta 0 is for that at the moment, and we'll see what that means in a couple of slides. So that's the pre and post for the control group. Now let's look at the pre and post for the treatment group. Okay, so the average outcome for the treatment group before the program was implemented is beta 0 plus beta 1. Well, how do you get that? Well, it's quite straightforward. Let's see. For the treatment group, then the value of the treat is going to be equal to 1. Before the implementation of the program, the value of the post is going to be 0. So treat equal to 1, post equal to 0. Okay, so in that particular case, you're just left out with beta 0 and beta 1 since the value of treat is equal to 1. So the outcome, the average outcome before the program was implemented for the treated group is actually beta 0 plus beta 1. Okay, now what is going to be the average outcome of the treatment group after the program was implemented? Well, in this particular case, then the value of the binary variables are actually going to be 1. So for the treatment group, so it's going to be equal to 1. For observations after, it's going to be 1. And so given that treat is equal to 1 and post is equal to 1, we're going to have beta 0 plus beta 1 plus delta 0 plus delta 1. So the same exercise, we can do pre and post for the treatment group, and so you get a pre and post of delta 0 plus delta 1. Okay, so this is where the focus should be here. So we want to take the difference in differences across periods between the two groups. Okay, so the difference in differences is going to be delta 0 plus delta 1 minus delta 0, and this is going to be delta 1. So the parameter that identifies the impact of the policy, the treatment, or the intervention is going to be delta 1. So that's going to be the parameter on the impact of the intervention. Okay. So just going back to the whole idea of doing the DID, so the first difference that we did is the before and after for both the comparison and for the treatment group. So we want to do this first difference is to control for characteristics that do not vary over time within that specific group. Okay. So the second difference that we did was to actually control for time varying vectors that affect the both groups. So for example, the economy is growing, and the effect of that economy is growing affecting both the treatment and the control group. Or the general labor market is better, so it's actually affecting both the treatment, individuals in the treatment, and individuals in the control group. So we use the before and after outcomes for the control group to actually clean the effect of changes that affect both groups. Okay. Now, given the same table that we have here in the slide, we actually going to be able to identify the weaknesses of the before and after method and the with and without method. So let's do the first one. What if we just compare the price of the treated group before and after? So what if we do just the pre-post that we see? So remember, in this data, if you do pre and post, the estimated effect of the garbage incinerator is going to be positive 39%. Well, that's good news for if you're someone who want to invest in the incinerator, listening to the fact that the house prices are actually increasing, but actually that estimate is probably biased. Okay, so let's discuss why that could be biased. So as you can see here, if you just do the pre and post, there is going to be this delta 0. Again, the estimate of the impact given this DID model is delta 1. So the bias is going to be delta 0. And what is delta 0? Well, going back to the model, delta 0 actually tells you, the average changes in outcomes across time. It could be like, again, the general macroeconomic condition, the general labor market condition, or other factors that changes over time. This is the time varying factors. Now, if you just do the pre-post method for this kind of analysis, then you're going to be identifying the effect of that intervention and other factors that vary over time. So here you cannot really isolate the impact of that particular treatment. Okay. And the second case, this is something that we actually did. What if we just compare the price of the treated and the control group post the intervention? Again, this is going to be the with and without method. So the with and without method, of course, we can extend it by including control variable here. So the control variable, I'm gonna encapsulate this on a factor x. It could be the size of the land, the size of the building, and so on and so forth. So again, we're going to produce a bias. So how big is the bias? Remember, delta 1 is going to be the estimated impact in this framework. So the bias is actually going to be beta 1. Now, if we go back to the equation, what is beta 1? Well, beta 1 is going to tell you difference in the average outcome between the treatment and the comparison group even before the program was implemented. So this is where kind of like the selection issue comes in. This is where the purposive program placement issue comes in. Okay. So just to give you guys a better understanding on the concept of the DID, I think this particular graphic is going to provide you with that intuition. Now let's think of a counterfactual scenario where what would happen if there were no treatment. Okay, so if there were no treatment, then the outcomes between the treatment and the control group are going to be similar. Okay, in this particular graphic, that similar is depicted as a parallel change between time. So you have a parallel change here for both the comparison and for the treatment group. So again, this is a counterfactual scenario. What would happen if there were no treatment? Well, now if we take into account the treatment, this is going to be the illustration. Now, due to the treatment, then the outcome for the treated group is not increasing as high as the outcome of the control group. So in some sense, what we're going to use here, the counterfactual for the treatment group is actually the trend of the comparison group. Okay, so what we want to do here is just bring this estimated increase in the outcome for the comparison group and use that as a counterfactual for the treatment group. So the counterfactual for that is, suppose that there were no treatment, then the outcomes for the treatment group is going to trend the same magnitude as the comparison group. Okay, so the difference in differences is going to provide you with, so the difference in differences is going to provide you with an estimate of the impact, and the estimate of the impact is going to be the actual outcome that we observe after the implementation of the program, and the counterfactual, and which is this, and this is going to be the estimated impact with the DID framework. Okay, so going back to the analysis of the incinerator effect, so the treated group is going to be houses that are located near the incinerator, and the control group are going to be households who are located far away from the incinerator. So you have an idea on that. So let's write the model for that. Of course, the outcome of interest is going to be the price, and here we're going to use the log of price. And then we're going to have a variable that indicates the time or the pose, and that's going to be y81. An indicator of treatment group, in this particular case, is the near ink. So if you're located near the incinerator, you're going to be treated as the treatment group because you're experiencing the negative externalities of this garbage incinerator. And also you have an interaction between the pose and the treatment variable. Okay, so again, what's your hypothesis on the impact of garbage in incinerator, and what parameter is actually going to provide you with an answer to that hypothesis, and what's going to be the sign of that parameter? Okay, so just going back to the discussion, so this particular framework may make the controlled experiments in science by finding something that happened naturally to one group of people but not to the other. This is also referred to as the quasi-experiments or the natural experiment. Okay, this is a very useful tool for impact evaluation in general, and of course this is one of the arrays of tools that we have for microeconometrics. And what is going to be the counterfactual? again, the counterfactual is that suppose that there were no treatment, then the treatment group, the outcome of the treatment group is going to trend in a parallel fashion with the control group. So the basic question that people ask about DID model is that, are we just satisfied with the basic model where we include the treatment variable and then the pre and post variable and the interaction between the two? Well, the answer is that yes, of course, if you have information on the variables that would affect the price of the houses, I think you should include that in the model. So in this particular case, I'm going to have several variables that in the factor x that may affect prices of the houses. That includes, the age of the houses, the square age of the house, the distance to the highway or the interstate in log term, land, area in the specification model. Again, going back to the first meeting that we had, if we're able to take away variation that is in the residuals, then we're going to lower the standard errors, the variance of the model in general, and then it's going to reduce the standard error, and it's going to improve the precision of our estimate. Okay, so with that, I'm going to bring you guys back to Stata, and we're going to provide you with an illustration on the different approach. Okay, so just to look at again the variables that are available. Okay, so let's look again on the variables that are available. Again, our outcome of interest is going to be lock-off price. We also want to include a dummy for before and after. We also want to include a dummy for the treatment variable, which is the near ink. So let's just start with a very basic DID specification. So we're going to do a linear regression of lock-off price on a dummy year y81. So this is equal to 1 if it's in 1981, 0 otherwise. We're going to include near ink, so this is the treatment variable, and we're also going to include an interaction variable between y81 and near ink. Of course, we also want to include robust standard error just to account for possible heteroscedasticity structure in the data. So let's hit enter. Okay, so given this particular specification, the estimated effect is about 6%, so negative 6%. So the average prices of houses located near the incinerator were lower by 6% in comparison to those far away from the incinerator. So basically, the estimated effect of the incinerator in this particular case is negative 6%. Now, of course, we shouldn't be happy just by having this particular regression. So what we're going to do is we're going to add more explanatory variables. Okay, so let's look at explanatory variables that we can use. Of course, we discussed about age, square of age, and then the distance to the interstate. We can include the number of rooms. We can include the number of bathrooms. We can also impute the square footage of the house area, the square footage of the lot or land into the regression model. Okay, so let's do that, and let's impute the exploratory variable in the model. So again, it's going to be lock-off price and then y81 near ink, and then y81 near ink. Okay, and let's add the control variables. So we have age, square of age, and then the size of the square footage of the house in log, and then square footage of the lot in log as well. this distance to the interstate, and then baths, and then rooms. Okay. Now, after we impute or include some of the explanatory variables, that may explain some of the variations of the prices, now the estimated effect is no longer 6%. It's actually now it's negative 13%. So the estimated effect that we obtain from the previous regression, which is from the basic DID specification, is actually underestimated. The impact of the garbage incinerator is actually higher than the 6% that we estimated. Is actually now 13%. So what would be the reason on why the previous estimation was underestimated? Well, the first thing that we can argue is that, well, the characteristics of houses far and near the incinerators are very different, and so that difference could be correlated with near ink, and so not taking into account those factors could lead to a bias estimate on the impact. So that's one. Another thing is that after the inclusion of this explanatory variable, since they are all relevant in explaining prices, we can get actually a lower standard error, although it's just marginally lower, but it still improves the precision of that estimate. So given this DID estimate, we can say that indeed there is a negative impact on the garbage incinerator, and we estimate that the impact is about lower house prices by 13%. Okay, so let's now discuss about the issues that we may face with DID estimation. So the first issue is actually probably not an issue, but I think the first main assumption that we want from a DID model is actually the parallel trend assumption. So a potential problem with using only two periods is that the control and the treatment groups are maybe trending at different rates. So remember the earlier graph that we have. We assume that the treatment and the control group are actually trending parallelly. There will be an issue if the trend is actually not parallel. So for example, the trend for the control group is actually steeper than the control for the comparison group, vice versa. Okay. So in the incinerator example, what happened if the prices of houses nearby the incinerator was decreasing at a faster rate than those from the incinerator? So in this particular case, or non-parallel trend, we may obtain a bias estimate on the effect of the garbage incinerator. So to solve this problem, we either get another control group or more years of data, preferably at least 2 before the intervention. So going back to the incinerator data, not only do you want to get the 1978 data, but perhaps you can get your hands on the 1975 data and the 1972 data. So you have at least 2 more periods of observations before the program was implemented, and see whether there is a parallel trend before the implementation of the program. So that's going to be the key parallel trend assumption. So if we look at the literature, so there's this paper by Cart and Kruger trying to evaluate the impact of minimum wage. I think this was one of that brilliant studies back in the time. However, I think the main comment that a lot of people gave them was that, well, hold on a second, are we sure that the 2 areas with and without the minimum wage are actually trending at the same rate? That was the issue that their study had. So given this knowledge, I'm hoping that if you want to apply some sort of a DID analysis in the future, not only that you want to establish a model for the estimation of the DID, you want to make sure that you have that parallel trend assumption. Yeah. So again, going back to the earlier graph and the graph that you're currently seeing now, you can see that not only that we observe one period before the implementation of the program, we're actually now looking at 3 periods before the implementation of the program. So you have observation t, and then observation t minus 1 and observation t minus 2. So this is going to be kind of like the parallel trend assumption that we want to show. So this is just a basic graphical analysis that you can show given this method. Okay, so given the parallel trend assumption, and then after the implementation of the program, the trend for the treatment group deviates. It could be higher than the trend that is expected or lower than the trend that is expected. Then the difference between the expected trend and the actual outcome is going to be the estimated impact of that particular program. Okay, so again, the estimated impact is the difference between the actual outcome and the estimated outcome given the trend. Okay, so that's going to be the estimated of the impact. Okay, so just to get you through the the inner mechanics of this DID model, so you can recall the earlier identifying equation that we have. And so to have unbiased estimators, we need to have the following assumption. So there is no correlation between the factors that we do not observe and the treatment variable. I guess this is the standard assumptions that we want to use. And also we want to have an assumption there is no unobservable variables that is correlated. There is no correlation between the unobservable variable and before and after. And we also don't want to observe any correlation, or we're going to assume there is no correlation between the factors that we do not observe and the way that it's actually trending. So the last assumption here, this is also known as the parallel trend assumption, and this is the most critical assumption. Now suppose that there are factors that we do not observe and it's actually specific for that particular subgroup, either the treatment or the comparison group, and that affect the trend, then the whole parallel trend assumption is going to falter and we're not going to be able to get an unbiased estimate from the DID. Okay, so again, the parallel trend assumption is quite crucial for the DID setting. Why? Because again, with all these microeconometrics methods that we're going to learn this semester, what we want to do is we want to obtain a valid counterfactual for each policy evaluation. And the parallel trend assumption actually guarantees you that you have that counterfactual for the treatment group. Okay, and what is the counterfactual? It's actually the trend for the comparison group, conditional on them having a parallel trend. So again, we assume that in the absence of the program, the outcomes in both the treatment and the comparison group must move in parallel manner. So I'm going to provide you with an illustration on what would happen if the parallel trend assumption is not fulfilled. So you have the comparison group illustrated by the red dots, you have the treatment group illustrated by the blue dots. So as you can see here, the comparison group is actually trending at a slower rate. So as you can see, the line is actually flatter than the treatment group. So what would happen to the counterfactual? Since we're using the control group as the counterfactual for the treatment group, you can see that the comparison group trend is actually flat because the comparison group outcome is relatively flatter across periods. On the other hand, as you can see, the trend in the treatment group is actually a bit steeper than the comparison group. So the trend in the comparison group is relatively flat, but the trend for the treatment group is actually a bit steeper. Now, if you still use the DID for this particular setting, then the estimated impact that you will get is going to be the difference between the actual outcome and the counterfactual predicted by the control group trend. So what you get is that an estimated impact that is higher than the true impact, which is the difference between the actual outcome and the trend for that particular treatment group. So the DID estimate is going to be higher than the actual. So here's the key. We never ever going to be able to identify the counterfactual. Okay, so you have to use this logical line of thoughts to know whether this is going to be overestimated or it's going to be underestimated. So for this particular case, since the treatment is actually trending in a steeper manner, but then the trend of the comparison group is relatively flatter, then the impact the true impact is actually higher than the actual impact itself. So in this particular case, it's going to be overestimated. So in general, difference in differences model is actually very, very useful. However, I just want to bring you to the attention that in order for us to do a robust difference in differences model, or to obtain a robust estimate from the DID model, we need to fulfill that parallel trend assumption. Of course, this is just a basic DID model, and there are more variations than we know. So for example, there is this continuous DID model. So instead of just switching the treatment on and off before and after, we also get that intensity. So it's there is no treatment before the treatment was actually implemented for both groups, but then for the treatment group, after the implementation of the program, it's not just they receive the program, but the magnitude or the intensity of that program itself. So that's a continuous DID, and of course, if you look at the way that the ID is presented here, basically you can work this with panel data. So you can see that for a particular observation, you can see outcomes across time, and you can actually build a trend for that particular unit. So there is a trend for that particular unit, and so if there is a change or deviation from that trend, that's going to be the estimated impact for that particular individual, and we're going to aggregate everyone in the panel data for that. So that's variations of the idea. Of course, there are more like what would happen if there is a staggered introduction of policies, and what would happen if the intensity of the policies are different by subgroups, and so on and so forth. So that interesting development out there. Keep an eye on papers that uses DID. You'll be amazed on how this DID model actually develops across time. Okay, just to give you a perspective on issues that we may face with the estimation of the standard errors. Again, in the previous example, in this data, since we have a very limited data and we have a just basic illustration of the data, we didn't fully take into account the issues with the standard errors, and so we're just gonna assume that it's okay. But there is this paper by Marianne Bertrand, Esther Duflo, and Sendel Mulenathan in 2006. So basically, the paper asked by how much should we trust in differences estimate. So it's not about only whether or not the estimate is biased, but it's also about the precision of that estimate. Is it a relatively precise estimation, lower standard error, or is actually imprecise, so higher standard error? So what we ideally want to do is actually we want to use kind of like a cluster to take into account outcomes that are correlated across years, and error terms or unobservable that are correlated across years as well. So the estimation of the standard errors should take into account this correlation, and with modern data package or modern R package, you can definitely apply this cluster robust standard error such as the Eker, Huber and White sandwich estimator in a straightforward manner. So it's not going to be quite difficult. It's going to be quite straightforward in terms of using a software to do that. but I just wanted you to have that, research design mindset that, hey, I have to be very careful in estimating DID model, particularly if you have outcomes that are correlated across years, or if you think that the unobservables are actually correlated across years. It's actually more conservative to assume that that way, so we can always apply the cluster robust standard errors. Okay, so the last portion of the discussion in this lecture, I'm going to provide you with another twist of the difference in differences models, and it's relatively, I don't think it's recent. It's actually been used in relatively old paper, and I think it's quite brilliant in the sense that we're going to take advantage of another layer for this. Okay, so let's start with how we should think about policy evaluation and how can we take advantage of this triple D model. So suppose that a particular local government implements a policy that affects a subpopulation, for example, the elderly or only the poor. Okay, so for this particular example, so that you're not confused, let's just take an example where a particular local government is implementing a program specific for the poor people. Okay, so I'm just gonna cross out this at least so for you guys not to confuse. Okay, so let's think about that local government. So if you think about the population, you can divide it into two subgroups, the poor population and the non-poor population. Okay, and so given your knowledge on the DID estimate, you can think about how to evaluate the effect of this policy. Okay, now it's interesting that there are actually two ways or two differences analysis, so two DID model that you can think about. Name the two. Okay, well, the first evaluation that you can think of is the following. Remember, you have a local government, okay, and there within that local government there is a poor subpopulation and there is the non-poor subpopulation. Well, you can do difference in differences with that two groups. So you have the treated group, the poor population subpopulation, and the comparison group, the non-poor subpopulation. That's one DID method. The second DID method is that, well, you have this local government, and perhaps you can actually observe adjacent local government, right? And the adjacent local governments actually also have poor subpopulation and non-poor subpopulation. Okay, so what you can do is that you can evaluate using DID using the poor subpopulation in your local government and poor subpopulation in the other local governments. That's the second DID. So the triple difference actually combine both DID. So it's a differences between the poor and non-poor subpopulations within that local government, and poor subpopulation in the local government that receives the treatment, and the poor subpopulation in the other local government that don't receive that particular treatment. Okay, so again, just to provide you with a generalization, we can include another local government that did not implement the policy and we still have that poor subpopulation in that local government, or a treatment group within the treatment within the treated local government. Okay, so let P represents the local government that implements the policy, and C is the other local government, and let G represents the group affected by the policy. Again, that's the poor subpopulation, and then G the group not affected. Okay, so it looks a bit intimidating, the specification model for the triple difference model, but it's actually relatively straightforward. So We have an indicator for the local government that implements the policy. So this is the kind of like the policy unit or the policy space. And then we have the group that is affected within that policy area. We have interaction between the local government and then the group that is affected by the policy. And of course, with all this differences, we want to see before and after for the 2DID. Okay, so the first one is DID for poor and non-poor subpopulations within the treated area, and then before and after for the treated group within the local government and the other local government. Okay, and then we also want to do an interaction term between the post and the local government and the post as well as the group that is affected, and our parameter of interest is going to be delta 3. So delta 3 is going to identify the impact of the implementation of the program in this triple D process. Of course, the assumption of parallel trend still holds in this particular setting. It's just a different way of showing how the trend is actually parallel, because we now have 2DID kind of in this triple D model. Okay, so let's look at what delta 3 actually looks at. Okay, so the first thing that we will see is that we see the difference in time between the affected group. So the group that is affected, we're going to see the observation before and after. So this is the first. And the second one is that this is the difference across time for the comparison group within the treated local government. So again, you're going back to that local government. You have the local government, you have the poor subpopulation, and you have the non-poor subpopulation. Okay, so that's one DID. And then the other DID is that you go to a different local government, but also observe the same poor subpopulation. Okay, and this is the third, kind of like the third, the DID. So this is the first, DID, and then this is the second DID. Okay, so now let's focus on each component. Okay, so again, the first component is just the difference across time for the treated poor subpopulation in the treated local area, and then this is going to be the control within that local area, and this is going to be the changes across time for the poor subpopulation in the local government that didn't implement the intervention. So let's see what each of these components do. Okay, so the first component here, it cleans out unobserved characteristics within the poor subpopulation within the local the treated local government. The second component actually get rid of the factors that do not change over time for the comparison group in the local, the treated local. And if you subtract the first and the second component, you're cleaning the impact that affects both the poor subpopulation and the non-poor subpopulation within that local government. Okay, so it's cleaning out the time trend within that local government. And the third component is useful to get rid of the components that change over time specific to that poor subpopulation. So for example, suppose that for the poor subpopulation, at the same time, in addition to the program that is implemented by the local government, the national government actually provide them with some social protection program. It applies to all poor population, poor subpopulation in all regions. And so that the triple D actually cleans that other effects that may affect the DID the triple D estimate in general. Okay, so this delta 3 is usually called the triple D estimate. Okay, so that's going to be the end of the lecture. And if you're interested in looking at the papers, these are just some very limited examples. Of course, there are 100 more people out there that actually take advantage of DID model and the variance. So I encourage you guys to see it. And in the next opportunity, we're actually going to discuss a particular paper by Esther Duflo on the impact of a school construction program that was enacted in Indonesia back in the 1970s. It's a very interesting paper. I invite you guys to read it. It has some history in it, specific to Indonesia as well. So it's a very interesting read. Well, thank you so much. It's been a pleasure for me to deliver, basic idea of difference in differences. I'm hopeful that you'll be able to get the basic intuition, master the basic intuition of DID, so that if you see any kind of like policy setting that you want to evaluate in the future, DID comes up to mind, and then you know how to implement it. Okay, so I invite you guys to learn against data independently, given the data set that is going to be provided, because I think that's going to be quite useful in you knowing how to do technical stuff. All right, it's been a good time talking about this difference in differences model. Thank you so much, and I'll see you in future opportunities. Okay, so it's been a pleasure to discuss difference in differences model and one variation, which is the triple difference. I'm sure there are more variants of DID out there. It really depends on the setting of the program that you're trying to evaluate, or the policy that you're trying to evaluate. However, I'm hopeful that you get that basic intuition, so that when this particular setting, you're going to be able to implement DID. Okay, so also hopeful that you're going to learn data independently, just to make sure that you're also sharp on doing technical stuff. Okay, it's been a pleasure. Thank you, and I'll see you in the next opportunity.